Students, previous lecture we learned block diagram of 8085 microprocessor and various registers and units of 8085 microprocessor. During normal operation, the microprocessor sequentially fetches, decode and execute instruction one after another. The fetching, decoding and execution of single instruction is that is the instruction cycle. Okay, in simple way, see the diagram here. See the concept of instruction cycle, machine cycle and T-state. Okay, and during normal operation, the microprocessor sequentially fetches, decode and execute instruction one after another. The fetching, decoding and execution of single instruction, that is instruction cycle. In simple way, instruction cycle is defined as time required to complete execution of instruction. Time required to complete execution of instruction. Okay, this is the instruction cycle. Next is a machine cycle. And instruction cycle is defined as time required to complete one execution of instruction, and each memory or IO operation require particular time period. Okay, each memory or IO operation require particular time period called machine cycle. So the machine cycle defined as time required to complete any operation. Time required to complete any operation. Okay. So the machine cycle. Now you see the T-state. This is a T-state. T-state is a subdivision of operation. See here, this T-state is a subdivision of operation. Machine cycle is the time required to complete any operation. Okay, this is the one operation. And T-state, T1, it is a subdivision of operation which is performed in one clock period. It's called T-state. T-state. It's a T2, T3. Okay, therefore, we can say that one instruction cycle 8085 consists of 1 to 5 machine cycle. 1 to 5 machine cycle. Okay, one instruction cycle in 8085 consists 1 to 5 machine cycle, and one machine cycle consists of 3 to 6 T-state. 3 to 6 T-state. That is 3 to 6 clock periods. Okay, this is about the instruction cycle, machine cycle and T-state. Okay, got it? I'm again repeating the instruction cycle. Instruction cycle is defined as time required to complete execution of instruction. Okay, then machine cycle. Machine cycle is defined as a time required to complete any operation. Machine cycle is a subdivision of instruction cycle. And T-state. T-state is a subdivision of operation which is performed one clock period. It's called T-state. Okay, T-state is a subdivision of machine cycle. Got it? Now, after that, we see the addressing modes in 8085 microprocessor. Okay. To perform any operation, we have to give the corresponding instruction to the microprocessor. Each instruction programmer has to specify three things, that is operation to be performed, operation to be performed. Second thing is address of source of data, address of source of data, and third, address of destination result, address of destination result. The method by which the address of source of data or address of destination of result is given in instruction. It's called addressing modes. What is the addressing mode? Addressing mode means the method by which address of source data or the address of destination of result is given in the instruction is called addressing mode. The term addressing mode refers to the way in which operand of the instruction is specified. Okay, in simple way, addressing mode, the way of specifying data. What is the in simple way? Addressing mode, the way of specifying data to be operated by an instruction. The way of specifying data to be operated by an instruction is called addressing mode. It's called addressing mode. Okay. So the simple way, addressing mode is the way of specifying data to be operated by an instruction. In 8085, there are 5 addressing modes. Okay. See these addressing modes. Okay. 5 addressing mode. First one is immediate addressing mode. Okay. Immediate addressing mode. Second one is register addressing mode. Register addressing mode. Third, direct addressing mode. Fourth is register indirect addressing mode. And fifth is implied addressing mode, or you can say here implicit addressing mode. Okay. Now we start with first, that is immediate addressing mode. Immediate addressing mode. In immediate addressing mode, the source operand is always data. Immediate addressing mode, source operand is always data. If the data is 8-bit, then instruction will be 2-byte. If the data is 16-bit, then instruction will be 3-byte. Okay. In immediate addressing mode, source operand is always data. Source operand क्या होता है? Data होता है. Okay. So see the example. For example, MVI E 45 hex. MVI A, 45 hex. That is move data. This is the data. Move this data 45 hex immediately to the register A. Immediately to the register A. Okay. This accumulator MVI instruction. This is the operation. See here, 45 hex is the data. A is the operand. Okay. And this instruction move 45 data immediately to the accumulator. Okay. Now see the next example, that is LXI 3050 hex. Okay. See this example, LXI 3050 hex. That is load the HL pair with operand 3050 hex immediately. Load the HL pair operand 3050 hex immediately. Okay. Then see the next example, that is jump. JMP jump. In this jump instruction, here address. Okay, this is the operand here. Jump to operand address immediately. Okay, jump operand address immediately. Okay, this is about the immediate addressing mode. See, I'm again repeating, immediate addressing mode. The source operand always data. If the data is 8-bit, then instruction will be 2 bytes. If the data is of 16-bit, the instruction will be 3 bytes. See the first example, MVI A 45 hex. In this instruction, move data 45 hex immediately to the register A. And next example, LXI 3050 hex. And this instruction, LXI is operation, 3050 hex is the operand. Okay. And in this instruction, load the HL pair with the operand 3050 hex immediately. And third example, jump address. In this instruction, jump JMP is a operation, jump to the operand address immediately. Okay. So next instruction, that is the register addressing. In register addressing mode, the data to be operated is available, operand is available inside the register. In register addressing mode, use only registers. Okay. So in register addressing mode, the data to be operated in available inside the register and registers is operands. Okay, inside the register and register is operands. Therefore, the operation is performed within the various register of microprocessor. For example, see MOV. This is the example MOV A, B. In this instruction, B is a source, A is a destination, move is a operation. Okay. So move the content of register B to the register A. Move the content of register B to the register A. Okay. Now we see another example, that is add B. Add B. See, in this instruction, add the content of register A and B and store result in A. See, in this instruction, add the content of register A and B and store result in A. Okay. Now we see another example, third example, that is INRA. In this instruction, see, this is the operation. A is a operand. In this instruction, increment the content of register A by 1. In this instruction, increment the content of register A by 1, of register A by 1. Okay. So in register addressing mode, data to be operated is available in operand is available inside the register, and register is operands. Therefore, operation is performed within the various registers. Okay. In this instruction, we use only register. And here we use the general purpose register. All of you know about general purpose register in 8085, DC, DE, HL. These are the general purpose register. Now we see the next addressing mode, that is direct addressing mode. In direct addressing mode, the data to be operated is available inside a memory location, and that memory location is directly specified as a operand. The operand is directly available in the instruction itself. In direct addressing mode, the operand is directly available in the instruction itself. Okay, the operand is directly available in the instruction. In direct addressing mode. Now we see the example here. LDA 2565 hex. See, this is the example, LDA 2565 hex. That means load the content of memory location into accumulator. In this instruction, this LDA is an operation, this is the address. In this instruction, load the content of memory location into accumulator A. Here, operand specified within the instruction. Okay. Now see the next example, that is HLLD. LHLD. Okay. LHLD address. In this instruction, LHLD address, load the content of 16-bit memory location. In this instruction, load the content of 16-bit memory location into HL register pair. Now, again we see the next example, that is in 35. In this instruction, read data from port whose address is 35. Okay. Got it? What is the direct addressing mode? Okay. In direct addressing mode, the data to be operated is available inside the memory location, and that memory location is directly specified in an operand. Okay. the operand is directly available in the instruction. These are the example, LDA, LHLD. These are the example of direct addressing mode. Now we see the next addressing mode, that is register indirect addressing mode. Register indirect addressing mode. In register indirect addressing mode, the data to be operated is available inside memory location, and that memory location is indirectly specified by the register pair. See here, in register indirect addressing mode, in register indirect addressing mode, the data to be operated is available inside the memory location, and the memory location is indirectly specified by an register pair. For example, move A, M. See this example. In this example, move the content of memory location. M is memory. Here, move the content of memory location pointed by HL pair to the accumulator. Okay. Here, memory location. This memory location here, HL register pair contain 2050 hex. Okay, and this memory location address is stored in this HL pair and 2050 hex. Memory location contain data 35. Okay, so this data stored in accumulator, register pair to the accumulator. Move the content of memory location pointed by the HL pair, pointed by the HL pair to the accumulator. Now see the next example, that is LDAX B. LDAX is operation, B is a operand. Move the content of BC register pair. See here. Use here BC register pair, 16-bit data. Move content of BC register pair to the accumulator. Okay. It's about the register indirect addressing mode. In register indirect addressing mode, data to be operated is available inside the memory location, and that memory location is indirectly specified by the register. Now we see the next addressing mode, that is implied addressing mode, or you can say here implicit addressing mode also. Okay. Implied addressing mode, or you can say implicit addressing mode. Fifth one, addressing mode. For example, CMA. CMA. This is the example of implicit addressing mode. Here, CMA is instruction find and store the ones complement of content of accumulator A in A. In implied or implicit addressing mode, the operand is hidden. In this instruction, operand is hidden and the data to be operated is available in the instruction itself. See here, accumulators. This is the operand. In this instance, this is the instruction. CMA is the instruction. In this instruction, operand is hidden. Okay. So in this EMA instruction, find and store one's complement of the content of accumulator A in A. Now we see the next another one example, that is RRC. Rotate accumulator A right by 1 bit. Same here, RLC. RLC. In this instruction, rotate accumulator left by 1 bit. Left by 1 bit. Okay. So the implicit addressing mode. See, implicit addressing mode, operand is hidden. Okay, got it? In implicit addressing mode, the operand is hidden and the data to be operated is available in the instruction itself. These are the examples: CMA, RRC, RLC. These are the example of implicit addressing mode. Now in this lecture we see the 8085 microprocessor. There are 5 types of addressing mode. First one is the immediate addressing mode, then register addressing mode, direct addressing mode, register indirect addressing mode, and implied or implicit addressing mode. Okay, again I'm repeating one by one all these addressing modes. Immediate addressing mode. In immediate addressing mode, source operand is always data. You see the example MVI B, 55. Okay, in this addressing mode, data is immediately moved to the destination register. Then we see the register addressing mode. In register addressing mode, we use the registers only. Okay, as a source or the destination. Okay, we see the we use the registers only. Okay, you see the example MOV A comma B. Okay, so B is the source, A is the destination. Okay, register addressing mode use only registers. Okay, general purpose registers and accumulator. Then we see the direct addressing mode. In direct addressing mode, operand is directly available in the instruction itself. For example, LDA 2050 hex, that is the load content of memory location into accumulator. After that, we see the register indirect addressing mode. In this addressing mode, memory location, that memory location is indirectly specified by the register pair. Okay, and last addressing mode is the implied or implicit addressing mode. In this addressing mode, operand is hidden and data to be operated available in the instruction itself. Okay, for example, CMA, RRC, and RLC. Okay, CMA, find and store the ones complement of content of accumulator A in A, and RRC, that is a rotate accumulator A right by 1 bit. Again, this instruction we see in our next chapter deeply. Okay, thank you, students. We'll stop here.